Hello and welcome everyone, and by now we have discussed waterproofing in different elements of the structure, and we have discussed that waterproofing is a method of creating a protective layering around the building, preventing the water from seeping into the building. And especially waterproofing in basement is very important because basement is the portion which is expected to bear all the loads that is coming from the superstructure, and it should be really very robust. But what happens that water intrusion damages structural elements. So we can see what are the different types of water related problems which can occur in the basement. It can be that there is ponding of water somewhere standing in the basement, or development of white molds in the corner, or it can be a source of moisture in the basement, okay, and due to which there is development of a different kind of odor or a smell in the basement region. So all these are the problems caused by water. Now there are different types of sources of water's intrusion, and in this diagram it has listed almost 15 sources. Now what are those? It can be that the floor may be cracked, okay, and if floor is cracked, the subsurface water which is beneath the soil of the foundation, it will start coming into the floor. Or maybe there is fault in the drains, or it can be that the drain tiles are cracked, or there is honeycombing of the concrete, or there may be foundational crack in the concretes. And some other sources can be like the penetration from the pipes, or there may be leakage due to the insufficient mortar joint strength, और there may be एक्सटीरियर फ्लडिंग. हो सकता है कि बाहर से बारिश इतनी ज़्यादा हो गई होगी कि एक्सटीरियर फ्लडिंग हो गया हो. और मे बी द विंडो कैन बी अ सोर्स, विंडो वेल, because for the foundation the window acts as a window well, okay, and it can be that the sewer pipe may be leaking. All right, so you can see all these possible sources of water into the basements, okay. So that's why waterproofing becomes very essential. So the above pictures show all the problems imposed on the basements by fluid matter, and it can be gaseous or liquid, and this all makes the basement unhygienic and weak, okay. So the basement was supposed to carry out all the loads, but here the basement is becoming weaker. So waterproofing is essential at below grade areas to prevent water intrusion and structural damage, and it is generally done when the building is on or below the ground level. Flooding, water damage and molds are many of the causes that damage the construction. There are basically two types of waterproofing system, and these two types of system are based on which side we are providing the waterproofing measures. So if we are providing the waterproofing system on the attacking side from the external of the structure, that type of system will be known as positive side waterproofing system, and this is done from the attacking side, okay. And if the waterproofing system is implemented on the defending side, or the side which is opposite of the attacking side, that will be called as negative side waterproofing system, and it is done on defending side. So there are different sources of water intrusions, and the total choice of waterproofing system which we have to use is, it completely depends on the condition of the site. So we can see what are the different sources through which water penetrates into concrete. So the biggest source through which water can easily penetrate is the honeycombing, and then is the major cracks or the minor cracks in the concrete, and then there are the joints in the concrete, like expansion joints. Then it is the capillary action of porous concrete itself which is a source of water intrusion. And then there may be hydrostatic pressure which may be exerted from the soil surrounding the foundation. So that's why we choose whichever type of waterproofing system depending on the site condition. Alright. So a third kind of waterproofing system is also famously known as blind side waterproofing system. And of course in this system the drainage and the waterproofing membranes are installed before the concreting of the structure. Now the concrete or other walls are put into place later on, and it is a very difficult application to waterproof in this way. Okay, so most of the case we do positive side waterproofing system, and if not then we have to do negative side waterproofing system. Now if you see at the diagram of positive side waterproofing, it is the same side of the structure as the source of water, and it is designed to stop the water before it gets a chance to enter the structure and damage it. So positive side of waterproofing is done in this diagram, and you can see here that waterproofing system is done totally on the external side of the structure, mainly on the foundation, and that completely prohibits the entry of water. Alright, so this is more proactive approach, and this should be done in most of the structure because it totally avoids the entry of water from the very beginning. Whereas in the negative side waterproofing system, it is done on the interior side opposite of the water pressure, and it is most commonly used in remedial works, elevator pits, tank liners. So this is the diagram of negative side of waterproofing system, in which waterproofing system has been done on the interior walls, but of course you can see that water is entering into the structure and it is getting prohibited by the negative side waterproofing, but due to intrusion of water our structural foundation will surely becomes weaker in this case. So in most of the cases we try to prefer positive side waterproofing most of the time. Let's see what are the various types of positive waterproofing systems, and basically I have here classified it into 5 groups, and the first and the very common is sheet membrane system, then is the liquid applied system, cementitious waterproofing, and board protection system and drainage board. So the first 3 are most commonly seen and we have discussed it already, but let us see them again. So in these figures you are seeing the people are applying some sheet on the substructure. Okay, so in the sheet membrane system we use sheet membranes, and sheets are of uniform thickness and they are generally made of rubber, basically UV protected water and chemical repellent sheets installed in the positive side. Now when I say positive side means the external of the structure, means over these sheet membranes we have to pour our concrete and the bricks has to be used over these. All the RCC elements has to be done over these sheet membranes. That's why it is positive side reinforcement, and it thus prevents corrosion to the basement. Of course the water will not be allowed entry from the very beginning, so there is no chances of corrosion of steel reinforcement. So there are 2 types of sheet membrane system. One is the cold applied system and other is the hot applied system. In cold applied system what happens that in heating is not required, okay, and it is very easy to apply. You just use the sellotape like that, it is applied on the substructure, but it requires a lot of a skill, because if we just use it randomly then there may be intrusion of airs, voids or gaps into the seat membranes. So it requires to be pressed accordingly. And you can see in this figure, these people are applying the seat membrane, and it is cold application on a roof valley of a house. Okay. Now it comes in particular sizes, and hence overlapping has to be done. So you can see in this diagram, this is the overlapping region. Okay. And people overlap one membrane over another, and there should be no joints. Okay. Asphalt is the basic component here in the case of cold applied system. Now in hot applied system, what happens, that seat membrane is heated and then it is pasted. So you see, this is a seat membrane, and it has to be applied with some heating arrangement also. And you can see this worker is applying a seat membrane here. This is our seat membrane, and he is also applying heat along with the application of seat membrane, and he is doing it vertically on the walls. This person is applying the seat membrane in the hot applied system on the horizontal roofs. So here bitumen is the main component. Okay, because bitumen has to be heated. Whenever we use bitumen, just like in the road construction, bitumen is widely used and it is heated. So this hot applied system is majorly used in terracing or on the roof, and its basic component is bitumen, like asphalt is the basic component in cold applied system. Here overlapping is very less in this case, because we are already heating and applying it. It really sticks to the structure. So it saves money also, because we can use the same seat membrane over the larger area of the floors or the walls. But the disadvantage is that the vertical application is difficult and may cause accidents. So you see in these two figures, one is the horizontal application, this one is the horizontal application, and person is easily doing it with the help of his legs. But in case of vertical application, this is the figure where vertical application is being done, person is doing with his hand. Okay, you can't use legs, never. So there are risks and injuries involved in vertical application. But of course proper gears has to be weared in these cases. Now the next type of positive side of waterproofing system is liquid applied system. So here we again apply a membrane, and this membrane is not the seat membrane, this is a liquid applied membrane. Means membrane which is initially in the liquid form and then it dries and form like a membrane. And that liquid has a low viscosity, and it is used either on the horizontal or vertical surfaces. Now this is in liquid with a low viscosity, so it can be sprayed on the walls, and you can see in this figure that these workers are simply spraying on the walls the liquid waterproofing membrane. Okay, and on this case you can see that liquid membrane application is being done by the rollers on the roofs or the floors. Why terraces are most subjected to waterproofing? Because it is mostly exposed to the rains. That's why terraces is most susceptible, and they have to be applied with these waterproofing system. When we say lamb here means liquid applied membrane, and it is commonly used for 2-ply fabric reinforced application. It has fast curing and moisture curing. Elastomeric material cures into a seamless means without any joint, monolithic, the same meaning, and rubber like membrane. It has very low odor also, solvent free, and can be applied to green concrete. It is an excellent alternative to hot rubberized asphalt application that eliminate many logistical and environmental issues associated with a hot system. It is generally a thin layer, so multiple coating is done. and we can see different liquid membrane layers in this figure also. So the next one is the cementitious applied system of waterproofing, and they are the most commonly seen. Okay, they are generally admixture based or crystalline based cements, and it is a waterproofing compound for green concrete, and cementitious products are probably the easiest waterproofing materials to use, and they are widely available from suppliers of masonry products, and they are easy to mix and apply. So you can see in this figure the application of cementitious coating being done, and here on the walls this liquid cementitious application is being done, whereas in this case the spray application of cementitious coating is being done on the foundations. And the chief disadvantage in this case of cementitious products that they just doesn't stretch to any degree worth mentioning, and they will stand up fine to a head of water but will tolerate almost no joint or crack movement. So this is the case in which the block cavity wall waterproofing is done using cementitious waterproofing, but of course it will not resist the crack or the joint movements. So this is the chief disadvantage in this case. And the next type of positive side of waterproofing system is board protection system, and this is also a type of blind side waterproofing. And in this case of board protection system, we use protection course Vibraflex PC, and it is used for protection of waterproofing membranes from damage by backfill or construction traffics. Typical applications include plaza decks, roof terraces, and pedestrian concourses, tunnels, parking garages, and foundation walls. So here you can see the waterproofing is done by using the protection board, and thickness of the boards depends on the hydrostatic pressure, and you can see it is being done on the external walls. Here this is the protection board, okay, and this is in contact with the subsoil. This will resist the hydrostatic pressure. So thickness of the board depend on the magnitude of hydrostatic pressure being exerted on the boards. So these boards are sticked to the foundation walls or the exposed areas in the foundation. And in this figure also you can see the use of protection boards being used in the construction areas. Now a special type of protection board that is also rarely used and is most prominent nowadays is the dimple board. And in these protection board there are dimples like holes. Either the holes is in the trough side or it can be like crest side. Okay, so here it is crest dimples and here it is trough dimples. Like here you can see the super plugs and membrane cap molding is used to connect the dimple boards with the foundation elements. And these are one of the most versatile and effective drainage products on the market. So dimple drain sheets are used on everything from small residential basements to enormous commercial projects extending 50 feet below grade, and they can even be used horizontally, and they help in drainage. And board drainage is the fifth type of positive side of waterproofing system. And here various sumps and pumps are added to the basements. The water from the membrane like the dimple boards collect into the perforated pipes, and hence drainage is carried out using these pumps. So here we use perforated pipes like this, okay, at the base. Now these perforated pipes, what they carry? They carry the moistures or the water that is coming through the subsoil into these concrete elements. So when we have done block drainage type of positive side waterproofing system, and in that case we apply a waterproofing membrane on the external of the RCC elements, and then a sheet to drain is applied, and then there is filter fabric wrapped around the pipes, and this goes to the perforated pipe. Now what does all these different layers do? So these layers, what they do not allow the entry of the water from the soil to the structure. Now the water which was trying to come into the structure, now it will trickle down and slowly through the dimpled drains it will reach to the perforated pipe, and in this pipe the water will be collected and it will be drained. Okay, so this is how block drainage is being used in the positive side of waterproofing system. So this is another diagram where the same drain pipe, here it is being used, and all these membrane system which is used here is trying to trickle the water below, and the water reaches to these drain pipes. Alright, and the structure remains safe from water intrusions. So next comes the negative waterproofing systems, and there are three main types of negative waterproofing system. One is the crystalline cementitious system, second is the flexible cementitious system, and third is the fluid applied system. Now what happens? Cement based capillary crystalline waterproofing coating. So this is a coating of a cement based capillary crystalline. Now here crystals will start forming. So these crystals are cement based and they reach by capillary actions. So wherever there is cracks, either they are honeycombing or the major crack or the minor cracks or any type of voids in the cement concrete, what will happen that these crystalline based cementitious system will start forming crystals, and they will permeate through the concrete and they will try to fill the entire holes, entire cracks or the honeycombing, whichever are the potential sources of water supply from the external system to our structure. So it is a form of grey powder and is composed of ordinary Portland cement as base material and active chemicals, okay, carried by water. The active chemicals penetrate into concrete substrate and react with unhydrated cement granules to produce insoluble crystals. Now these crystals which is being formed by reacting with unhydrated cement granules, they are insoluble. They completely repel the water, so which block the capillary channels in concrete. Now the capillary action in the concrete, if it is porous, it will be blocked. So it making the concrete itself waterproof. When a small cracks develop in the concrete substrate due to internal stresses or external forces, as long as there is water, so the above mentioned reaction will happen again. So as long as these crystalline cementitious system are available, if there is water, so they will again start doing the reaction and crystal will be produced again, and it will try to fill the cracks, and it acts as a realizing self repair. And here in this diagram you can see the penetration of crystalline formation. So what is happening? Water is trying to come into the concrete structure, and here we have done a negative side of waterproofing system on this side. So what will start forming? Crystals, and these are the crystals which will start blocking the concrete in the capillary actions. Okay, and as long as there is water, more and more crystals will form, and the entire concrete structure will become impervious in that case to the water. Okay, so this is how the application of crystallization waterproofing is done against hydrostatic pressure. Next is the flexible cementitious system, and it's a polymer modified cementitious coating, and it can be applied either on the positive or the negative side using a brush or a spray, and it helps to fill up cracks. The flexible cementitious waterproofing products are two component brushable slurries or throwable mortars with exceptional flexibility destined to solve some chronic and thorny problems in the waterproofing industries. And few advantages of cementitious waterproofing system: it can be applied amply and with great flexibility in cases of bridge cracks. Even the cracks are existing or it may develop in the future, and it can withstand negative as well as positive hydrostatic pressures, and it has excellent waterproofing properties, and they are easy to mix and use, and they can directly accept tiles or water based paints. So you can see this is the spray type of waterproofing, and here flexible waterproofing system is being done using a brush. And in this figure you can see how flexible the waterproofing components are used in these cases, and you can mold it with your hand or with your simple tools very easily and apply it mostly for filling of the cracks or on the surfaces as a membrane. So this is how we do waterproofing on different system, either on the attacking side, which is called the positive side waterproofing, or on the defending side, which is called the negative side waterproofing system. So we will discuss more on the precautions that has to be taken while waterproofing or damp proofing in the coming video. So till that, stay tuned and stay safe. Thank you.